Hello, welcome back. In this presentation, we are going to talk about the state design pattern. The goals for this presentation is to present this pattern in the most clear way possible. We are going to start with a motivating example that will allow us to present the characteristics and the good use of this design pattern. We are going to represent the different states of our machine, of our state machine, as objects. And we are going to encapsulate in each of these objects the operations and the state transitions. Also, we are going to talk some details about how to handle the state machine state. We are going to start by analyzing an example where to apply this design pattern. We are going to have, in our example, an automatic coffee machine. The idea of this machine is that it will produce for us a coffee once we pay for it. So the machine will pass into different states. We'll start waiting for an order. Then once we select the beverage that we want, the coffee that we want, we'll wait for our payment, we'll do the coffee, and this coffee, once it's ready, it will be taken by the user. We can represent these states by this simple state diagram, where we start with the waiting for order. In this case, we call it idle state. Once the user accepts one order, we are going to pass to the second state, that is waiting for payment. The machine will stay in this to pay state until we pay enough money, and then it will start making coffee. It will continue making coffee until it ends and changing its states to coffee ready. As we see, we have 4 states, and the machine will be moving in these states during all its life. In this case, when we model this machine as an object, we are going to have exactly the same operations. We are going to accept an order. We are going to be able to tell the user how much is this order, so the user can put money to pay for it. That is the third operation. We are going to get the coffee done when it's ready, and we are going to be able to take the coffee from the machine. These are the operations that are exposed by our coffee machine. When we are having these operations, not all operations are available when we use the machine. They depend on the state that we are using. For example, we cannot enter money into the machine until we select correctly which is the coffee that we want. So if we model this in our Smalltalk code, we can see that our code starts having a lot of conditional questions, like this one, where we check in which state we are to allow the user do the operation or not. In this case, if we are not in the correct state, we are going to raise an error. So we are going to ask for each of the operation if we are or not in the correct state. Also, other thing that happen is that we are going to handle the state of the machine by hand. So in each of the operations, we are going to have mixed conditional code to check if we are in the correct state, code to handle the transitions of states, and then the real code that will do the actual operation. This start being much more complex than only having the real operation. So we can see that this pattern is repeated in all the operations that we have. In this case, we cannot ask the machine how much is the coffee that we want if we don't select it first or if we are not in the correct machine state. So we see exactly the same pattern again when we have to have a conditional code to check if we are in the correct state. Even when we have a really simple operation, that in this case is just returning an instance variable, we have a lot of boilerplate code that is complex and does not add to the final operation. So, what is the idea behind the state design pattern? Basically, is that we are going to have objects to represent our states. We are going to have our coffee machine, that is our subject, and it will delegate to another object the operations and the transitions of a state. We are going to have represent, in our case, for each of the 4 states, we are going to represent with a class, where we can implement the different behavior for each of the states. It's important to see, in this case, we have selected to have a common superclass for the states, but this is not needed, and just what we need is that they have the same interface or they understand the same message. In this case, we have selected to have a common superclass because what we are going to do in each of the operations in the common superclass is to mark them as invalid and just raise an error. In this case, so all the operations that are not supported by the current state will just return and will raise just an error. As I said before, the key point in this design pattern is that the coffee machine, the object that has the complex state, the complex state is a complex state machine, will delegate to each of the states the operations that we want to do. We have rewritten our method acceptOrder to send the message to the machine state, to the new object that represents the state. When we are in the idle state, the machine will send the message acceptOrder. We are going to do the lookup and find the correct method, and the code in the idle machine, idle state class will execute, and we are going to perform the operation, and we are going to change to the new state. We can see this pattern again in the other operation that we analyzed it before, that is how much is it the coffee that we are asking, and we see that we have the same pattern. We delegate in the machine state to perform the operation, in this case just returning the price. We have for all the states an implementation that raises an error because it's our default implementation, but in the correct state we are going to return the correct value. In this case, we have a lot of advantages. The idea is that in each state, in each object that represents our state, we are going to just implement the operations that we care on. Also, we are hiding in these objects, in this implementation, the state transitions. That in this case is simple, and we have a circular state transitions. We go from one state only to the next one and so on, but this could have been more and more complex. It gets easily more and more complex. We also have less conditional code. We are using much more delegation. We are using the idea of tell and don't ask. This eases a lot the reading of the code, and these properties that we are marking, like just implementing the needed operations, having encapsulating the transitions in each of the class of the states and having less conditional code starts being more and more important when we have much more states or more complex transitions. We have an additional point that is interesting to talk and to analyze in this design pattern is that where to put the instance state. When I say instance state, I mean the state of, in this case, in this example, the coffee machine. So we have to select where to put, in this case, the instance state of our coffee machine. In this case, in this example, we have just two instance variables, and we can select to put them in the machine object, in the coffee machine object, or each of the state objects that we have. If we put it in the coffee machine object, this is useful because this state is used by all the machine states. So they are common. They can delegate to the coffee machine to use the internal state of the coffee machine. When we change from one state to the other, we don't need to copy these values. So this simplifies the changing of one state to the other, but has a problem that in this example is not clear. But if we have a lot of instance variables in the coffee machine, we will need to use them. And the problem is if these instance variables are different from state to state. For example, in our example, if in the idle state we are using a set of instance variables that is different than the ones that we are using in the state while the machine is doing the beverage, is doing the drink. So the problem with that is that maybe we have instance variables that we are not using in all the cases. The other alternative that we can explore is if we put the state in the state object itself. We put all the instance variables, all the internal state of the coffee machine in its state objects. This is useful, is a great idea when each state of the coffee machine has different internal state. We need a different set of instance variables. It's also good because we can do that each state object can directly access this instance state. We don't need to use messages or sending accessors only to the machine, to the coffee machine. But it has the consequence that every time that we change an state, that we create a new state and assign it to the coffee machine, we need to copy, we need to pass all instance variables to it, and we have to pass the state from one state object to the next one. As a conclusion, the state pattern is useful and is used a lot when we have an object that has a life with many states, that has a complex translation between states, and that have different operations for each of the states, because it encapsulates the operations and the state transitions. So we use more delegation instead of conditional code. We just will delegate in the state instead of implementing conditional code, and allows us a more flexibility to add new states and new operations. Of course, as using any design pattern, this is a more complex solution than doing it directly. So we have to balance it and decide when we need to use this new complexity versus the clarity and flexibility that we win with using this new tool. As any tool that we have in our toolbox, there is cases when we are going to use it and cases when we are not going to use it. And it's important to understand the consequences, the positive and negative consequences of using one or other tool. In this case, the state pattern.